Good afternoon. Let's get started. Our speaker next week will be Doug Arendt. Doug is the Executive Director of the Joint Institute for Strategic Energy Analysis at the National Renewable Energy Laboratory. He will talk to us about rethinking our energy future, grand challenges and opportunities. Doug, at his center, has been leading a range of different studies on very broad aspects of energy, not just in the US, but globally. And it will be a special occasion to have him speak to us here. It's a great pleasure to invite one of us, Dave Tuttle, here as our speaker today. Dave is a very special person, and he holds the special distinction of perhaps being the person who has been most engaged with the Energy Symposium over the last 4.5 years, only after me. So I have attended most, in fact, all of the symposia, but Dave has the distinction of being here and engaging as in the audience in discussions with questions, but also I can tell you how much engaged he has been after the talks with a number of speakers on a range of issues. He is a really multifaceted person, and we are delighted that he is with us here today, but also on campus generally. He's a research fellow and a PhD student in the Department of Electrical and Computer Engineering.
Candidate, I passed my qual.
You did?
Oh, yeah.
He's a PhD candidate. See?
No, you don't have to do that. That's just like...
For those of you who are still PhD students, it's a big change. Congratulations, Dave. His interests are in plug-in electric vehicles, smart grids, especially in the interaction of plug-in electric vehicles with the grid and renewable energy more generally. He has a couple of decades of experience in variety of capacity. Towards the end of it, actually as executive capacity in companies like Apple, IBM, Motorola, Sun Microsystems, leading a range of R&D projects for microprocessor design, high-speed fiber optic-based adapters and switches, including being a part, in fact, lead of one of the teams that helped design the Power 2 SC microprocessor that helped defeat the world champion Garry Kasparov in the blue chess, the deep blue chess game. He has been at UT for some time now. He actually got his MBA degree from here and won the Dean's Award for that. He holds a bachelor's and master's degrees in electrical engineering from University of Louisville. And he'll talk to us today about 2015 state of electric vehicles. So he'll give us the state of the vehicle address here. Welcome, Dave.
Thanks. So I've got some electric vehicle groupies, co-groupies in here too, so I expect a lot of good conversation. So let's go through the motivation status, factors affecting adoption. And I want to make this a little bit more broad than diving into the technical details of vehicle-to-grid integration or batteries in particular, just that, because when we talk about adoption, there are other things, somewhat soft factors that are affecting adoption too. And so what I want you to all become is aware of the big factors and the interesting factors, and over the next decade, a lot of interesting events are going to occur. And I want you to be able to recognize those and say, well, we thought about that, that's interesting that that's now transpiring, or just see how it evolves, because it's a rapidly evolving situation. We've seen that even over the last 4 years that the mass market vehicles have been available. Key trends, some advanced vehicle capabilities, and we'll summarize. So the classic motivations, I gave a lecture in the energy, technology, and policy class, and so I actually had this chart, and I had these top sort of big societal motivators there, and I thought about it, and yes, they're all important, absolutely. Why do we as a country or any country want to look at alternative fuel vehicles? Well, you worry about the trade deficit from importing oil. Maybe it's not $1 billion a day now, it's only $500 million a day. We see oil price shocks and spikes that tend to precede recessions, so it can impact it. It acts like a quick acting tax hike whenever oil prices spike. We've seen petrodollars in the past go to organizations or groups that are certainly counter our interest, if you've ever read the 9/11 report. The biggest supplies are from regions that are fairly unstable, and of course lower emissions. But the fact is, most people buy a car, sure, a lot of us early adopters for these reasons, but they tend to buy a car because they really like it, right? And so the technology itself, if you talk to someone who's owned one for a while, they tend to be ones that are really advocating it because it's such a great vehicle. And you can make a superior vehicle with this. And I don't have a Tesla, but I have a Volt, but I have to just say that Tesla keeps redefining over and over again what is possible, and they demonstrate how a superior vehicle can be implemented with that technology with electric drive. So, as far as the gasoline prices, this is EIA on gasoline prices from 1991 to about today. Obviously a lot of volatility. Went way up, some people say it helped precipitate the 2008 crash, and then when the economy cratered, then it came back down, then it rebounded. But look at the electricity price since 1960. It's hard to beat electricity, getting cheaper over time, getting cleaner over time, and fairly stable. And if you do the math, it comes out to about $1 a gallon. So it's not as attractive, compared to when gasoline is $4 a gallon for the electric equivalent being $1 a gallon, but still even at $2.50, it's still half the price. And it's a lot more stable. Where are we at as far as adoption? Well, one proxy to look at that gives a decent basis of comparison that we've used in the past of analysis of the electric grid to see how clustering effects might appear in distribution transformers were Prius. And the Prius first came to the US a little bit later than Japan, but it first was introduced in the 2000 model year. So using that as an analysis baseline for adoption of advanced batteried, motored electric vehicles, semi-electric vehicle in that case, if you look at where we're at right now, after 4 years, there's actually been a much wider variety of electric vehicles and a more rapid adoption rate. So I want to put that in perspective, though. That's good, but there are 231 million vehicles in the U.S. They tend to last a long time, and the average year now has grown to be, average age is about 11 years. About 16 million cars are sold a year on a good year. Got down to 8 or 9 when the depth of the recession. So it's going to be quite a long time before you have the turnover of the whole fleet, but a lot of progress is being made, and it's being made at a decent clip. And it should just accelerate with a variety of factors I'll talk about in a little bit. So here's some recently announced vehicles, either announced or already available. This doesn't have all of them. That's why I put the website down if you're more interested so you can see the additional ones. These are the ones that really caught my eye as far as most meaningful. Here's an update to the Model S. The 70D is an all-wheel drive dual. They just announced that. It increases range and also has all-wheel drive and about 240 miles range. The BMWs were announced last year. That's the i8. That's a very fast car. It's really kind of neat. It has gull-wing doors. It's about $120,000. It's very fast. Actually, though, interestingly enough, it's not as fast as the P85D Tesla. The P85 Tesla is just simply awesome as far as performance. The smaller car there is the i3 BMW that you've seen buzzing around. I've got a neighbor that has one. This just got announced at the Detroit Auto Show in January, the second generation Volt. And so that's going to be available in dealers maybe around September timeframe. Everyone knows about this, so what's that doing to the first generation that's still on lots? That's kind of making the existing vehicle inventory not be sold very fast because everybody's waiting for this one to come out in a matter of months. We see other German companies of substance. I think VW is number 1 or number 2 in the world as far as global manufacturing. That's their e-Golf electric version. The Bolt was announced also at the auto show, and they said it was a concept, but they've actually confirmed they're going to put it in production. The meaningfulness of this, along with Tesla's Model 3, is both will be a 200-mile battery electric at about $30,000. And there's different discussions about is it before or after tax credits and such not. But that's a meaningfully disruptive point, because once you have that much range, you really are in good shape as far as an around-town car especially, maybe even intercity travel. The Kia Soul gets good reviews too. So a lot of vehicles are coming, even more than these. So it's interesting. I've talked to people who don't seem to know that much about cars, especially don't seem to know a lot about electric vehicles, and they seem to want to say that electric vehicles, and I quote, suck. Okay? And I say, well, have you ever driven one? No. Have you ever really talked to someone who's owned one for 4 years and driven it well, no. If they have, they haven't really listened. If you listen to Consumer Reports, the number one customer owner-satisfied car is a Tesla Model S. For a couple years in a row, it was the Volt. The Volt's been relegated down to number 3, behind the Tesla, the Porsche 911, and now the Volt. Okay, so the people who actually put their money on the table, buy these, use it every day, are generally very satisfied, and they love them. Purchase prices for the non-luxury, and the reason I point that out, that distinction, are generally still higher. The technology has to decline. The battery prices have to decline over time. Have to be engineering improvements and technological progress. And I say non-luxury because if you look at a Tesla, it competes with Mercedes, Audi, BMW, Lexus, Infiniti, Cadillac, and such on, and it's price competitive today in that arena. Long-term durability is promising. All the people I talked to have had good luck with the cars. But it's yet to be proven because the cars have only been on the road, say, 4 years. I'm optimistic because we heard many of these same concerns in 2000. And I have articles I've saved over the years when the Prius first came out. Oh, it's got batteries and they're going to fail too early. Oh, it's more expensive. It doesn't pay back. You'd almost take out some of those phrases, those words about Prius, and plug in your favorite electric vehicle and put them in, and it would read like an article just published today. But I think there are ways to make the batteries last with the right thermal management and competent design. My perception is, from engaging, is there are a few of us that really know the differences and the subtleties of the vehicles, but generally, and understandably so, because so many people have so many other things in their lives to deal with, understanding the idiosyncrasies or the subtleties of the different types of vehicles is just not one of their priorities in life. But there are substantial differences. And so I don't think the general public really knows exactly the differences of these vehicles. There's a difference between a 200-plus mile range Tesla and how you really can use it, or a RAV4 EV, and an 83-mile Leaf. They differ as far as what you can use, but there's still a lot of situations there where people don't understand. The plug-in hybrids basically solve range anxiety, and people don't think sometimes that these are electric vehicles when in fact they are, and most of the driving, a lot of your driving can be electric, and there are varying types. You know, a Prius plug-in that's a compliance car only sold in California, it only gets at most 11 miles range and not above, say, 40 or 50 miles an hour. The new Volt has 50. They have vastly different types of driving experiences. And depending upon your drive cycle, your commuting needs, they'd have vastly different profiles as far as how much you can drive electric and how much you have to drive on gasoline. But the fact is there's all this talk about, well, battery vehicles, or PEVs, that's why I use that more generic term, plug-in electric vehicles. Well, they really only go 83 miles and you get stuck on the side of the road. Well, no, not if you get a plug-in hybrid. It basically runs as an electric vehicle, and then after that it operates like a hybrid, and you could go from New York to LA just as you would a conventional vehicle, stopping at gas stations, but if you commute around town. So I see a lot of times when people don't really understand the subtlety. And right now, there are, even though there's a wider array of vehicles being offered every year, if you wanted a convertible, there's no convertible plug-in electric vehicle sold. They stopped production of the Roadster a number of years ago. If you need a minivan, They don't make a minivan yet. So it's just the start. The powertrain and the other components are still being developed and improved. So we're still at the early stages of this. I say we're nowhere near iPhone 6 or Galaxy 6S level. We're probably even pre-BlackBerry or Trio 650, for any of you who even remember those. Anybody here remember BlackBerries or Trio 650s? Okay, so we're at the early stages. And you have to realize that conventional vehicles running on gasoline have been developed for more than 100 years. So we're just at the start of that, of mass market viable electric vehicles. There were many in the past, a century ago, but I'm talking about ones that really have the power electronics, the batteries and such not, and the architecture like a plug-in hybrid to be able to be mass market viable and not be making you sacrifice as a driver of anything. So there are a number of well-regarded vehicles there, but again, not all the different vehicle types. They're still learning, the vehicle manufacturers, how to create compelling electric vehicles. So fundamentally, people want to get excited about a car. They're going to spend so much money on it. And it takes effort, and it takes focus, and it takes a real desire to want to do it and make a winning vehicle. I don't think all the vehicle manufacturers do that. They make mistakes on conventional vehicles. Every conventional vehicle isn't a sales success. Every conventional vehicle is not a compelling vehicle in my view. There are some certainly less than compelling. But there are some that are making an earnest effort. We'll go through some of that. And there's some that are making basically compliance cars because they want to sell into California. And California has certain standards from the Air Resources Board that force manufacturers to invest in R&D to try to nudge them into producing some of these cars. And not only that, I think most of the enlightened ones are seeing the 2025 federal CAFE, corporate average fuel economy regulations, being something that they are concerned about and investing in technology strategically to meet those. But I'm hearing actually nowadays that they've made a lot of progress on conventional vehicles, and they know that they have to invest in electrification to a certain point, but by lightweighting cars and downsizing, turbocharging, direct injection, and all these extra widgets they're putting in conventional vehicles, they're not going to have a majority of their vehicles being electrified to meet the 2025 standards. So if they want to create compelling products to sell a lot, they have to really understand. Compliance cars, everyone, even though I'm not trying to be overly negative on these, everyone that if you read the tests, they tend to get good reviews as far as being fun to drive, but they're typically only in California. You may not even be able to buy it. For example, that Honda Fit EV, I think it's lease only. They take it off the road after 3 years. You can get a good deal, but they're doing it. They're losing money on it, offering it lease only so they could take it back so they don't have long-term support. But people kind of love it. I don't know, how many people, I know you two, have seen Who Killed the Electric Car? Okay. So you know about how they took back the GM cars and they crushed them all and such. Well, part of that's logical. If you're not making money out in the first place, right, having it around where you have to maintain spare parts and training and such not makes it even more of a money-losing situation. So I could see it, but still. We have an owner of one of these cars in the room here, and he loves it. It's got a Tesla powertrain in it. It's a compliance car. It was basically only sold in California. You got it here somehow. The Fiat 500e is well regarded. People love it, but the CEO of the company, Fiat, complains about it costing them, they lose $10,000 per copy, and he's trying to discourage people from buying it. So, okay, what are the attributes of a compelling vehicle? So, well, styling. Even if you really don't care about styling, it just can't be ugly or it's repelling, right? So styling matters in a way. The utility, the purchase price, or if you really look at it and do some more analysis than people tend to do, more than the back of the envelope, the total cost of ownership that includes maintenance and fuel cost. Performance, fun to drive. Does it have lower emissions? Are you doing something better for the environment? Energy security, that's actually one of the many that I think is an advantage, trying to get us more energy secure. Leading edge technology, people like to experiment. And refueling time, location, and convenience. And you may say that this is actually a big negative, but what I've learned over the 4 years is actually it's a huge positive, because I go to the, if I go look at my log maybe 3 times last year to the gas station to fill up my Volt, and the rest of the time I just plug in overnight, like my cell phone. And when people say, well, electric vehicles, they take so long to charge versus standing at a gas pump holding it, the fact of the matter is, and I've measured it because I'm an energy nerd, I always come here, it takes me about 12 seconds to reach for the plug it into the car, another 12 seconds to put it back when I leave. And that's the effective time that I spend refueling my car every day, because you don't have to sit there and hold it like a gas pump. Okay, the computers take care of everything. You plug it in and you walk away and the computers take care of it. And so it doesn't matter if it takes 4 hours for me because it's overnight. And so that's a great convenience to me. I actually met an interesting gentleman the other night who had a Model S. And so I, of course, had to ask him if it's the new P85D, which is the super high performance, 3.1 seconds 0 to 60 that beats everything but a Porsche 911 GT3, okay? And so that kicked off the conversation. It turned out he was in real estate. And he has driven in 2 years of ownership of that car 65,000 miles, okay? And I thought at first, wow, do you drive back and forth to Dallas? There's a charging station that Tesla put up at the Collins Street Bakery in Waco. It's a really beautiful bakery. And he said, no, it's been totally around town because he's in real estate and he's always showing real estate properties, okay? So you start doing the math of how that car has been an advantage for him already today, already being, you know, a superior vehicle. It's like the quote, best car Consumer Reports has ever tested. So it's a great car. But if you look at the gas savings, on top of that, many luxury cars have oil change intervals of 5,000 miles. So he saved, what, 12 or 15 oil changes at perhaps $100 an oil change. The brakes last longer. And on top of that, with that kind of drive cycle, he'd be going to the gas station probably twice a week. So think about all the time you saved not having to go to the gas station by simply plugging in at home at night. So there's actually a huge convenience factor of that. And there's new functions like vehicle to home. That's using your home, your vehicle as a backup node. So I thought about it because the reason I wanted to put this chart together is to give you some view of who you ought to pay attention to and when, okay? Because I'm really not trying to be a Tesla fanboy or an Elon Musk fanboy, but they are really impressive. Maybe sometime they'll get that rocket to land on the pad there without blowing up, right? But they keep redefining what's possible. And if you go study the history of the Volt, you'll find out that one of the ways they got funding for that was the fact that the vice chairman, Bob Lutz, could point to this little California startup that had done this Roadster, the red car right there, that Roadster right there. And he said and because they had a really bad taste in their mouth from the EV1, okay? They had movies that were made that really made them feel bad. If you talk to GM people, that movie really, they feel like it's a little bit unfair, I think. And it was effective. It really helped make the Volt happen because they felt that they really weren't evil in doing that. But the board of directors really realized that if this California startup from Silicon Valley can do this, and we're the largest auto company in the world, we can do this. And so the competitive response aspect of that was of huge value. So I give a fully committed, redefines what's possible repeatedly. They bet the company, A+, okay? Then you get the leadership, GM, Nissan, and BMW, for example. And you might have some extras that you think should be in these different categories. But I give them an A-, solid, really. leadership, fairly substantial investments, over $1 billion, if not more. They don't really bet the company. It would hurt, but it wouldn't take it down. And they help out also in standards activities, for example. And GM with the Volt, Nissan with the Leaf. Nissan made a huge bet, billions of dollars with the Leaf. And they really redefined what the electric vehicle could be. They deserve a huge amount of credit. BMW, these new i3 and i8 vehicles are carbon fiber and aluminum space frame. And so they're using it to push forward technologies that they wouldn't otherwise be investing in. That's going to trickle down to their other products too. So it's a big investment, multi-billion dollars. They get an A in there too. There's the solid participants that are more than putting their toe in the water, invested, but they haven't gone whole hog and they haven't really created as compelling of vehicles because they tend to leverage their gasoline vehicles. So for example, I've driven this Ford Fusion. It's a quite attractive car, plug-in hybrid. It's called a Ford Fusion Energy. And it was a really nice car. It has about 20 miles range, which I feel is a little bit short because I'm spoiled with the Volt. But what they did is they engineered it so that they could manufacture it on the same assembly line, use the same basic car, and they put a battery pack, they stuff it in the trunk, and they do all these things so they minimize their R&D effort and they minimize the number of changes, and they get their feet wet and get some learning. That's valuable. It's not as compelling because you have to really engineer the car differently to get a much bigger battery to have a 40 or 50 mile range, but they get a good effort. You know, Porsche with the Panamera e-hybrid, the e-Golf that I mentioned. And then there's the laggards, and I purposely didn't leave off the names, but we'll talk a little bit about it, that, you know, I don't know, you can give them a grade, but they create the compliance cars. They're really not into it. Sometimes, like that Fiat 500e, they outsource their R&D, and sometimes they outsource their manufacturing. They really don't try. And in some cases, they actually talk about their other strategies and don't have any other vehicles that are electrified, like Toyota. And the other one there is the Honda. So I searched earlier today to see if I could get any of these plug-in hybrid Hondas or Toyotas in Austin, which is usually an early market for electric vehicles. And they're California-only cars. Toyota loves hybrids and fuel cell vehicles. They really are not partial to electric vehicles. So you say, well, I thought charging infrastructure was the big problem. That's the huge impediment. We don't have all these charging stations all around. Not really. I mean, I think it's one of them, especially for pure battery electrics. But a plug-in hybrid eliminates that. I didn't bring in my charge cord. It looks just like this. It's in the trunk of my car because I never use it hardly because I have a level 2 in my house. But you can plug it in to any 120 volt outlet. So people say, well, we have 160 or 170,000 gas stations in the U.S. Think about with 61 million detached owner-occupied homes alone, and I think there's 100 and something million households according to the Census Bureau. But think about how many different outlets you have, because electricity is the most pervasive energy distribution. The grid is the most pervasive energy distribution network in the world, especially in the U.S. So you have literally tens of millions of potential recharging, refueling points with electricity. That's one of its advantages. And with a plug-in hybrid, you don't get stuck. If you can't plug in, that's okay. The gasoline engine is kicked on by the computer, and you just drive. And it just operates like a hybrid. And since the batteries are smaller, you can even use this level 1 cord to still charge overnight. I know the former manager of Austin Energy, who was an early Volt owner too, he's still using, after 4 years, that level 1 cord. It's that easy. He didn't pay a dime to go get any level 2 or anything special hooked up in his garage. Battery electrics are progressing too. Right now, more around town. There's still a limitation if you go out of town. Tesla's leading the effort to build out an infrastructure for intercity travel with their supercharger network, but still, you can still conveniently charge overnight. is an issue with street parkers. Say you live in an apartment. Many of you might. Where would you plug in? You might run an extension cord out of your window, but what happens if you live second or third floor? That's more of a challenge, and that's where I think the charging infrastructure will evolve. And there's some people from Germany I met from Berlin that had this very interesting concept. So I don't know if you can see it. It's a wireless charge cord. It's a charge cord that has a wireless meter in it. And so they've worked out with the city that the light post will have these outlets, and the way you pay your bill is you plug in your special cord that has a wireless meter on it, and it knows your account number, and it measures how much electricity, and it bills your account on the street. I thought that was brilliant. Okay, that's an idea. Also, I think we'll see over time more local DC fast charging, which really has a much faster charge rate that can charge, say, in 20 or 30 minutes. And a vision that I had is, and this is where I'm trying to set the stage for you all for 10 or 20 years, you all have heard about autonomous vehicles that drive themselves. That's a technology that's going to come around. Who knows if it's going to be, I don't think it's going to be 5 years, maybe 10 years, maybe a little bit more. But imagine that you lived in an apartment and you had an autonomous battery electric vehicle and it had wireless charging. So wireless charging is where your vehicle just parks over this inductive coil and the energy is transmitted instead of with a conductive wire, the charge cord, inductively. Just like you're seeing now with some cell phones where you can do inductive charging, but this is higher power. So imagine you just have it drop you off, or you get out, to your apartment after work, go in, and you command it to go get charged. And so it goes and negotiates a charging reservation at a wireless charging refueling station. Maybe it has to wait for a little bit, so it finds a place to park temporarily. Then when the place is available, it perfectly aligns because it's a self-driving car. It charges, and then when it's done, it gets out of that spot and then waits until you tell it to come get you in the morning. All right? So you have your own valet that takes care of it. And since it's wireless, it doesn't need any human intervention to go plug this cable in. That, not only would you not have to park your own car and find a parking spot, that's a compelling technological advancement in terms of convenience. So the other thing is on the interstate, so the supercharger, even with the biggest battery Tesla now that can go 260 some odd miles, you can charge it in, say, 20 or 30 minutes. And they're very cleverly placing these as much as they can in locations where you have far more things to do than spend only 20 minutes there, okay? They have one between here and San Antonio and San Marcos at the Premium Outlet Mall. So you can go there and spend money and shop for hours, right? And it's no big deal. The Collins Street Bakery in Waco on the way to Dallas is a fantastic place. Stretch your leg, get a cup of coffee, relax, 20 minutes, you're done and you're on your way. Charges it up with quite a bit of range. But at home, I did some searching to make sure I had the latest numbers. We have 61 million in the U.S. alone, owner-occupied detached homes. And this means to me that you could have even more, a greater number. And the average number of cars per home is 1.9 cars per home. So if you do the math, about 50% of the U.S. vehicles have the chance of parking. We're at 300,000 electric vehicles on the road now. We could potentially, just charging at home, maybe even having greater opportunities, have 116 million. So we're way far away from saturating and worrying about not having enough charging locations necessarily. But level 1, you could have a level 2, which makes it faster, lightning, and then that's the supercharger. How many people have had 5 to 10 minutes, okay, great experiences with dealers, car dealers? Well, so how many people have heard about the debates about Tesla trying to sell direct? Everybody? Okay. So I've talked to like the chairman of the Texas NADA, Texas Auto Dealers Association, when he was actually trying to fight Elon Musk 2 years ago at the last legislative session to say, don't let them come into our state and sell directly, right? I want to sell any kind of car. Well, you know, I think that they have that attitude, but if you go down to the real sales floor, there's actually it's quite easy to find examples where salespeople have really discouraged the sales, and they don't know a lot about the cars. It's a harder sell, and such not. So the Tesla sales bypasses this. Basically, you set up, if you go up to the gallery or you go online, you set up a test drive. You can talk to the people at the gallery and see it, and then you basically order it online on the internet. And it's like Amazon. It just shows up at your door. Okay, and it's just that easy. And the service is just that easy too, because they come to your house, they drop off a loaner, and then they take your car and you go pick it up when it's done. How many people have heard about Apple potentially creating an electric vehicle? That could be a real disruption. So who are the buyers today? Urban residents that have houses. It's going to increase as we have a number of models proliferate, price premiums come down, and consumers get more educated. And disruptive events to watch are 200-mile battery electrics, Apple EVs, and such not. Here's an important point. There was a recent study, and this is an interesting counter. About 4 years ago, there was a National Academy study on battery technology in electric vehicles, and it was fairly pessimistic as far as progress on batteries. This has actual data from the last number of years, and the prices have come down a lot more than people have kind of expected. So that's working. I'll go a little bit faster. This is an interesting chart because it's such a complex concept to try to get across, so I used it from a McKinsey study. And this was from about 2012, and so I used 2011 numbers. And you say, well, where is it competitive? Meaning, where can you get the car? Where in battery prices and gas prices will these different types of vehicle be competitive? And I interpreted that as when the price is attractive and then the vehicle manufacturer can make a fair profit to be interested. Gas prices have come down, obviously, from there, because you can see where the 2011 box was, but also battery prices have come down too. And so I think progress is being made on that. Tesla seems to be the leading edge. The other thing, not only is it batteries that are declining in price and cost for the manufacturers, the power electronics. Every generation, about every 4 years, they re-engineer the power electronics, become lower cost, higher density, lower weight, lower cost, and that helps reduce the cost of the vehicle. But for a plug-in hybrid, there's also been innovation for that range extender. So BMW's got this 2-cylinder for the Rex and the i3. This is a very interesting, I put the link to the SAE paper on this, and you can get these papers from the UT Digital Library. And it's a generator, and it's basically this free piston. And so it's a W-shaped piston, and instead of having an engine that turns gears, that turns a generator, it just goes back and forth, and the W-shaped piston has a magnet around it, and then you have this wiring around that. And so that creates this very simple generator. So it's very innovative. And then we've got the other. So where are we heading? So I don't know how many of you really felt like you observed the digital camera revolution. I remember buying my first digital camera and talking to people who were professional photographers, and they said, well, you know, still I like the richness of film. And this chart I got from a vision of the train wreck that you could see coming, because silicon was moving ahead. Kodak at that time was still making money on film, but you could see that over time that they were going to converge. And I would bet very few people in this room still use real life film cameras, but you could see it coming. Right now, the price premium for a non-luxury vehicle generally is thought to be about $10,000, or maybe that was a few years ago, because I think the prices have come down. And so if you take a fairly modest price decline curve, price improvement curve, say 5% or 8% per year, and then look over the next decade, 2015 to 2025, and then you look at what the estimates are from different entities quoting what it's going to take to improve existing conventional vehicles to meet the 2025 standards. You get a low estimate from the DOT or the US EPA saying it's going to be anywhere from 1.5K to say 1.8. So the price is definitely going up because they have to get more sophisticated. Meanwhile, we've got these technology curves that are driving the cost of electrified vehicles down. And so depending upon how you have the assumptions, it should be fairly close within a decade. So it's going to be very interesting to see. I wouldn't suspect, given their other superior properties, that they have to meet the exact same price point, but the premium will be down enough to where it'll be a much easier decision. And then there's the relative simplicity. This is a P85D or a 70D. Actually, it's a 70D because I think it has a smaller motor in the back. So this is an all-wheel drive performance sedan from Tesla. And if you look at the relative simplicity of that, okay, and this is a really beautiful A7 Audi. I don't know if they call it Quattro anymore, but it's an all-wheel drive RS. And if you look at the sophistication of that engine with all the different parts and all the different powertrain components to make that all-wheel drive high-performance system work, you can see a really substantial difference in the complexity of the powertrain. Complexity means cost. It means less reliability over time, probably less efficiency, I would think, too. And you see the beauty and elegance and simplicity there. All you have to do is get the price down. So what about other things that an electric vehicle can do that a conventional vehicle can't even think about? Interactions with the grid. So it's one of my areas of research is vehicle-to-grid integration. And honestly, we haven't had that much success yet with having huge DR, demand response, as far as the grid operators, the utilities, using electric vehicles. They don't tend to have as much DR anyway, trying to do DR on air conditioning and water heaters, unless it's a certain market like Florida. That's moving forward. The electric vehicle is like a beautiful potential source for demand response to help increase the stability of the grid, make the economics of the grid even better. And it's a huge new revenue source for the grid operators at the same time they're losing revenue because people are making their homes more efficient with LED light bulbs and such not. So there's a lot to be had in peak shaving by intelligent charging. Also moving the load to the bottom. If you see the trough there, that's every day you have this peak and trough around here. Everyone goes to sleep, electricity demand goes down, everyone goes to work or gets up and does things, and you need air conditioning, peak. There's a huge amount of capacity that's underutilized. You have to design the grid for the peak. Otherwise you have blackouts or brownouts. But at night, that's underutilized. So if you just have your vehicles programmed to charge at night, it's a win-win. The other thing in particular in Texas is we have a large amount of wind, and it blows typically stronger at night. So there isn't much better than being able to have 100% domestically sourced, zero emission source at night to charge your vehicle. Wireless charging, I've mentioned that. So instead of even having to ever handle the coupler and plug it in, you just push the garage door opener button, and not only does the garage door open, but it takes over and guides the vehicle in your garage to perfectly park it over the charging spot. You walk out and it charges itself overnight. Vehicle to home, that's where the backup generator function or a storage node, if you have outages out in the country and your grid isn't reliable, you could actually use your vehicle as a backup generator. And there's concepts called vehicle to grid where you actually put power back into the grid to help shave the peak and help the grid get more stable. You can't do any of that. So here's a picture of my E-gauge. This is really showing my nerdiness. So I have solar panels on my house, and the green is where my generation from the solar panels is more than my load of my house. And so it's net metering, it's pushing it back on the grid. And this is where I came home, plugged in my vehicle, charged it, left, came back later on. So the output of my panels is about 2 to 3 times what my car needs a day. I don't really try to necessarily align it with when the sun is shining to do that. I just don't, have the time to do that right now. But I at least put energy back at the grid with that zero emission, and I took some out later on. But the fact of the matter is, today you could even do a zero emissions car. So what I think is going on is the base technology is demonstrated. I mean, there are there's hundreds of thousands of happy electric vehicle owners out there. I will tell you they love their cars, and the technology is safe. We don't see any of these cars blowing up. That's another thing that you might hear, well, these cars, huge batteries, lithium ion. Well, it all depends on the year, 160,000 conventional vehicles burn up every year. Everyone here in this room, I bet, is driven by a car on fire, okay? How many electric vehicles have you heard on fire? You've heard maybe 2 or 3, the Teslas that ran over this huge piece of metal in the road, and then they pulled over safely, the person got out, and it burned up, okay? So, and that made all this news, but the 168,000 that burn up every year don't seem to make any news. It didn't, well, and the people got out, right? And if you have this huge chunk of metal in the road that you accidentally hit, try hitting that with a conventional vehicle. Probably might puncture your gas tank too. I think that the growth will be regionally specific. It's very interesting. One of the biggest leaf markets in the country is Atlanta, Georgia. And part of that is the incentive. They get HOV access with one person in the car. And it's one of the biggest markets. So they sell more there than just about anywhere but California. The advancements are going to be continuing. I think it'll be, of course, at a modest rate. And you could draw that line that I did that was smooth, but it's going to be a step function where every 4 years or so a manufacturer will introduce a new big model and it'll be a stair step. And there'll be some occasionally very interesting disruptive events, like when Apple introduces their EV or new designs. I think that the prices decline. We've got many more synergies possible that we haven't yet exploited. We've got research going on it, but we haven't exploited it. And on the infrastructure, I've been on 3 DOE projects on electric vehicle infrastructure, and some of this is you'll learn along the way. It's going to be different for a 200-mile battery electric than it was for an 83-mile battery electric. And what you really need or believe you need is going to evolve. So it's already so easy. If you have a home, you basically can update your home to have its own personal refueling station, and it's permanent. Once you update it, that's the standard. The J1772 standard fits on all the vehicles. And so once you upgrade, you've got your house now able to charge your vehicle, refuel it. Okay? That reminds me of when we had time-sharing computers and you had to have these huge mainframes, and then you had a personal computer that you could take with you. Here you have refueling at your home easily. And then we have these other types of concepts for the other types of vehicles for different types of charging that'll be improving over time and evolving over time. So, got any questions? Here we go.
All right, students first, please. Thank you for speaking. One of the main problems that I've heard people come up with regards to for electric vehicles is the carbon cost of making the batteries that run a lot of them. Can you speak a little bit about that?
Yeah, you have to watch out. There was a study from one of the Scandinavian countries where they did what's called a life cycle analysis. You do well-to-wheels for the operation, and you do life cycle to include the creation of the batteries, the manufacture of the vehicle, the operation, and then the recycling. And when you really look at that analysis, it assumed the car only lasted 50,000 miles. And so when I talk to different auto manufacturers about the true life cycle analysis with a reasonable set of assumptions, not 50,000 miles, I already have 47,000 miles on my car. It's running fine, right? You amortize that upfront carbon cost on a much greater mileage base. So the average U.S. vehicle for a light-duty vehicle, pickups are, say, 178,000. Cars are about 151,000 from the last survey that I saw a few years ago. There's no reason to expect the vehicles can't last that long. And when you amortize it, all the credible studies that I've seen show that that's a minority portion. Okay. Or, where do you want to go?
Hey, so I had a question about, two questions. One, do you think that the lithium-ion technology that Tesla is producing now is the future of electric vehicles and how the batteries are going to work? And two, I don't know if you heard about Tesla announcing at the end of April a new product, which is rumored to be a demand response battery for homes. And so I don't know if you had any comment on that.
Yeah, I think that's one of the other ways. So let me give a bigger perspective. Honda created their whole business around being experts in internal combustion engines, okay? And it's said that they started off with motorcycles, and then they just figured out how to bend different types of metal around different ways to build cars, jet skis. I've got a Honda weed whacker, think of all the different lawnmowers and such not. Tesla is a battery and power electronics and battery management system. And they've learned also how to weld to bend different things around it. And that core strategy. So when you look at the sort of brilliance of having that core technology for the car, then building a storage business around it, then coupling it with a solar city, right? It all fits. And I heard one of the managers from Tesla talk about they expect their guesstimate is about 25% of the Gigafactory will go to non-automotive applications. And the other thing about this battery price decline is the sweet spot seems to be, I always try to probe on this for battery experts, what's the tipping point for grid storage? And if you look at the different government projects that are trying to drive prices down and advanced battery, it seems to be about $100 to $150, right? So there's nothing like automotive that drives up volume, that drives up quality, and drives down cost. So it's a very synergistic situation having those two coupled together. As far as lithium ion, when you say lithium ion, there's name the number of different formulations of lithium with different cathodes and anodes and such not. And then you hear about lithium air. That's one of the things I think it's really neat now is that it's stimulating so much more investment. Competitors are entering, governments are funding research, and over the next decade or two, we're going to see enormous strides. It's not going to be like Moore's Law. I used to design computers, and we expected to have to eke out 2x per 18 months. It's not going to be like that. But a good 5 to 8% is what my assumption was, talking to some experts. This latest report that I referenced there with the chart talked about we've seen, say, 9 to 14% over the past 5 years. Maybe it won't be that fast going forward, but still it seems like 5 to 8% is a reasonable number going forward. Well,
Students left.
Yeah, my question segues nicely from what you just talked about because of the declining cost of the batteries. What I wanted to bring up, and I think that everybody should take away today, would be a really interesting story of how much Toyota and Honda have invested in hydrogen fuel cells for cars and what their prospects are for getting those cars from what I understand, the Toyota Mirai as a hydrogen fuel cell they're launching this year. And I have some friends in New York that work at the Global Poverty Project, and they said, hey, we're featuring at Earth Day Toyotas. You know, forget electric, as my friend texted me. This only puts out water, so I kind of sent him some explanation.
Oh, but if the hydrogen is made through natural gas reformulation, it's not anywhere near as clean as an electric vehicle.
But what I wanted to mention was that, you know, hydrogen fuel cell car is an electric car with a fuel cell recharger on board, and you have to get the hydrogen, and the infrastructure is very expensive to put in.
Right.
So what are your thoughts on how hard they're going to land on their face when the batteries come down in price and then just blow any kind of prospect for hydrogen cars?
Okay, so let's take what you just said and add to it. So if you go look at the basics, a hydrogen fuel cell car is an electric car driven by a three-phase AC motor, right? The power electronics should be about the same. The software, which is a big effort, should be very similar. They should for the control system. You need electric heating and air conditioning systems. You need electric power steering, electric power boost for the brakes. All those systems should be common. If you could do this conceptually by taking a Nissan Leaf, shrinking the battery down to about the same size as a Prius, and sticking this fuel cell, which is an energy conversion device, to recharge that smaller battery. You always still have to have a battery in a fuel cell car for transients and regen and things like that. But you could conceptually say that's your range extender. You could say for a Volt, conceptually take out the gasoline engine, put in a fuel cell, shrink the battery again. They all should be having this common vision that they're going to build these building blocks that are common between the vehicles. And then they could probably try to plug and play. All they have to do is put a bigger battery in to do that, or a range extender. And that's why that Toyota, the interesting Toyota free piston linear generator as a range extender was very interesting when I saw that in an SAE publication. Is that maybe in the back they've gotten the R&D, some other things that are still exploring. And that runs on natural gas? Yeah, it could be a variety based upon what you design it for.
Howdy, sir. My name is Kevin Merrill. I'm a master's student at LBJ. So I'm a numbers geek too, and I crunch all the numbers. And you're probably the first person to ever say that I've read that it's about $1 a gallon, comparatively speaking, to charge your vehicle. So I'm not a denier about the benefits of an electrical vehicle, but I need to see the cost-benefit analysis. And I just want to make a quick point, and then I got a question because I don't know it. You showed a picture of the Bolt, the Chevy Bolt, $30,000. So I just went on Chevy.com, and the same kind of model car is about $15,000. So that difference of $15,000 would take 21 years in gas savings
so
to pay for it.
So the first thing you have to do is not compare what generally is a $30,000. I saw this with the Cruise.
Well, no, that's not true,
so
sir.
let me just finish.
Okay.
So when we first, actually, Google the paper I wrote with Kara Kokelman comparing a few years ago. It's on her website that we published in the Transportation Journal. So you don't compare an entry-level box at $15,000 that has no features with a fully equipped one. You have to have them comparably equipped.
I got that, sir.
Okay.
So
we saw that too. So compare apples to apples as far as stereo systems and sunroofs and all the things that you have to get sometimes with one of these vehicles. And I doubt that it's really $30K versus $15.
Well, I'm just going off of what the model shown on the.
Yeah,
it was
so
a quick
show
thing.
me- you can
But
show me.
I also drive a $30,000 sedan, and it's not that Chevy Bolt. It'll never be that. There's a level of luxury difference between a $30,000 sedan and that box with wheels that you showed up there. Anyway, that's my point about the cost-benefit analysis. But this is a question I really don't know. The trough that you showed on the electrical power grid, let's say we do get all the vehicles onto the electrical power grid and then that trough is raised. Are you saying that it's cheaper and more carbon neutral for electrical generation to come from a power plant versus a gas-powered engine?
If you do the wells-to-wheel analysis, you have to look at the different sources because there's coal, natural gas, nuclear, wind, et cetera. You'll have different emissions profile, but it's very hard to beat an electric vehicle. Electric motor is, say, just to give you a part of the equation, 95% efficient. A gasoline engine's a third of that. So even if you have 7% losses on the distribution lines, the transmission, you more than make up for that with the efficiency in electric motors. So there's a Daimler website that does well-to-wheels, or if you really want to get into it, Argonne Labs has a GREET tool for well-to-wheels, and it will show that the emissions are better. Credible sources.
Okay, I found interesting the part you talked about how when cars become intelligent, self-driving, and how it'd be much easier in order to get charging and valet and whatnot. But I wanted to ask, I've heard thrown around the idea that once cars become self-driving, there'll be more like communal usage and how, because you don't need the car all the time, you can just go to the next person. So how does all of this fit in with that perspective if we do go that way?
I think it's a great question. First of all, autonomous capability isn't unique to electric vehicles. It may have some particular cases. One of the things that the car companies are really scared of are a number of trends. Young people aren't necessarily as concerned about getting their licenses. Okay? They're getting older, for example. B, car sharing. So someone had a study that said that if you have a car sharing service, it could potentially displace eight cars. And so they see that as a threat to the number of cars they'll sell. So you're right. If you suffer by having to drive more than 2 hours a day, even just 2 hours a day, that means your car's sitting 22 hours a day. And that means that it could potentially be car shared. And if it's autonomous, it could be gasoline or electric. It could be where you share it, you reserve it for a few hours now, and then somehow some system sets up with or smartphone apps, the reservation system, and then you take it and you drop it off, and then it drives itself to the next location to where you want it. Absolutely. So that all plays, that's kind of independent to electrified or whatever the powertrain is, but the wireless idea I thought was very interesting. Good question, though.
You're out of time.
Oh.